Alright, so for two lights. For two lights. 6 meter length. Like this. Cool? For 3 lights. 3 lights. 6 meter length. So it's a 600. So it's a 6 meter. 6 meter divided by 3 equal 2,000. And then you say 2,000.
2003. Oh.
Yeah. Because this give 3,000.
So you change it now to 3 lights. Yes, sorry.
So only and then you say half. So 2,000 divided by 2 equal
lights?
1,000.
How many lights I use now?
3 lights. So 2,000 is space between. And this we should have put on Instagram, don't it?
No, I have it set. I'll go on Instagram.
Space between light. 1,000 start and stop. So for this you'll have 3 lights. 1, 2, 3 lights. So this you'll have 2,000, 2,000, 1,000, 1,000. So light 1. So this is what will happen now. So the first light would shine 1,000, 1,000. The second light would shine 1,000, 1,000. Because this light here would shine 1,000, 1,000. So every light would do the same amount. If you have for 4 lights, you do the same, which is the same 6 meter length. So 6,000, you divide it by the amount of light, which is 4. You get 1,500 here. Cool? So equal 1,500. That is the distance between lights again. And then you divide this. You divide this 1,500 by 2, which would give you 750. Would be start, where the lights start, and stop. So basically you have 4 lights. So this is for 4 lights. 1, 2, 3, 4 lights. So the distance between lights is 1,500. 1,500, 1,500, 1,500. Start and stop is 750, 750. So these two 750 make 1,500. It's 1,500, 1,500, 1,500, 1,500, which give you about the same 6,000. Cool? So therefore, just the same, this light here is able to shine 750 this way, 750 to this mark. This light here is able to shine 750, 750. Likewise, this light 750, 750. Likewise, this light 750, 750. So in this scenario, every light still do the same amount of work.
So comment on that one.
This light, so I came in and basically we had this light, and I'm actually explaining how you measure up spotlights. So at the moment, as you can see, there's shadows. There's shadows in the middle, and then there's light. Aesthetically, it doesn't look nice, and the formula works right the way around. If you want one light in the center, you would say, and for instance, this is a 4 meter length. You say one light in the center, you say, all right, 4 meter divided by 1, which you would get 4 meter just the same. You divide that by 2, which where you get the start and the stop, which would be 2 meter and each. So it would be 2 meter, 2 meter. Start to the light and stop. So it works right the way around. You understand? So yeah. If we were to go again, because we're working right the way through, for 5 lights. For 5 lights that you want to be evenly, and you're using the same 6 meter. You say 6 meter divided by 5, and that would give you 1200. So equal 1200. So the 1200 is the distance or the space. I can't spell distance, sorry. Distance.
Start and finish.
No. Distance between
lights.
Yeah, lights. So that is what you'd have, the distance between lights. And then, so you have 5. So this is for 5 lights. 1, 2, 3, 4, 5 lights. So you know the distance between each is 1200. 1200, 1200, 1200. Start and finish would be half of that. So start and finish would be 1200 divided by 2. The start and finish is always divided by 2. So it's half of what the actual distance is between the lights. So this would be 600. So equals 600 for start and finish. Excuse my writing. So 600. So if you notice, it would still add up to the 6,000, because these start and finish would be 1200, 2004, 3006, 4008, 6,000. Cool? So, and then again, each light would also do the same amount of work. Because this light here would be able to shine 600 here, 600 here. Whatever shadow would be on both sides. This light here, 600 here, 600 here. This light, 600 here, 600 here, 600 here, 600 here. This light, 600 here, 600 here. So each light in the equation does the same amount of work. Final one. For, yeah, I have to get some work done. Today's Friday. I won't get paid. For 6 lights. Cool? For 6 lights, you do the same. You divide it by the amount of lights. The length is still the same. For 6,000 meters, that's the length. So we say 6,000 divided by 6. So, which would give you the space in between lights. Pens are finished. Instagram, need to buy me a pencil. Yes, the space in between light is 1000. That is the space. Space and distance is actually the same. It is actually the same. Let's say SBL, space between lights. No comments. So, so that's 1000. So for 6 lights, you'd have 1, 2, 3, 4, 5, 6. And this is 1. Yeah. So fast forward here. So we have 1, 2, 3, 4, 5,000. And then we'll need the start and stop. So the start and stop is always half of the distance between the lights. So the distance between lights is between lights is 1000, and you divide that by 2 to get your start and stop, equal 500, which would be start and stop. Okay, so this is 500 here, 500 here. So, and so that would be like the center like illumination.
Lux.
Yeah, so this light here would be able to shine 500, 500, 500 to this line, 500 to this line. This light is able to shine 500 to this light, 500 to this line. This light 500 to this line, 500, 5. So right the way throughout, you find that each light is doing the same amount of work. If there is if there's an overlap here, you'd have an overlap here. What you find that if you ever install light that's close to an edge, that's close to an edge, and it's pretty dark, when you turn the light on, you'll be able to see that illumination doing like that. And if you follow this formula, those illumination or the lights that you'll see on the surface will be an exact triangle right the way throughout, because all of the lights are doing the same amount of work. Even if it overlaps, you'll get that right the way throughout. An exact triangle right the way throughout, showing that each light is doing the same amount of work. That's our lesson for today.
Alright, there you have it, people, so we don't want to see no more of that.
No more.
Alright?
Good.
Alright, just hit like if you like this video.